Hello everyone, this video I will explain KinCony ESP32 energy meter board hardware design details and software solution details. Okay, let's look at hardware firstly. Okay, you can see this is N30 because I have opened this box. We also have N10, N20 and N60. And this is a energy meter board. This is a tester and this power supply. And I have connected with this heater. This heater will power about more than 1000 watt. So this is used for test and connect with the CT sensor and two different CT input port. Okay, let's look at details. Okay, you can see this is our testing environmental. I will power off. I will show you this PCB design in details. So I will power off and remove it. Let's look at this one. This is CT sensor. And this is power voltage, AC 220 volt at here. Okay, let's look at this PCB design. And this is a cover. I just remove this because I want to see all details at here. And I will show you the hardware principle, how CPU works. And this board, you can see, this board have two PCB. I just remove this board. This is a OLED display, I2C OLED display, and this SD card. And this board and connect with this bottom board by these pins. That will connect with the ESP32 S3. And this one, you can see this board. This one is ESP32 S3 CPU. It's a Wi-Fi module, but it's a CPU. And this board have two CPU. You can see at the bottom of the PCB that have a CPU. This is ARM CPU that is deal with this energy meter chip at here. So you can see this is input. This is 30 channel input of CT sensor, and go to this smart board. This smart module made by BL0910. Just this energy meter chip, this one, BL0910. So you can see this N30 will have three smart modules. So this one manages this 10 CT sensor, and the second smart module manages this 20, this another 10 CT sensor, and this one from just 21 to 30 channel of CT sensor. And at here you can see that is power. You can see L1 and 1, L2 and 2, L3 and 3. They have connect with this 3 transformer. So that will detect power. If you use single phase, so you can connect with L1 to leave line and N1 to neutral line. But if you want 30 channel all used by yourself, so you need to connect with this L2 and L3, just connect together. Because you can see every one energy meter chip that can manage 10 channel CT sensor and 1 channel voltage, this AC voltage. So this one manage this CT sensor and L1 and N1. So this managed by this smart module. And this second one, the second one manage this CT sensor and L2 and N2. And the third one managed by this CT sensor and manage this L3 and N3. So if you want connect monitor only less than 10 channel CT sensor, you only connect with this L1 and N1 to your AC 220 volt leave line and neutral line, because this enough have 10 channel. But if you want connect 11 or more than 20 channels, just use this one and this one. But also you are using single phase power system, so you need to connect this L2 and L3 and connect with this L1. And because this energy meter chip that will calculate the power and calculate the energy consumer according to the voltage. So if you have connect only L1 and N1, this is no power. This is no power. So that will only detect the CT sensor current, but no power and no energy data. So if you are using single phase and more than 10 channel CT sensor, you should connect L2 and L3 together with this L1. Okay, this is the first single phase case. But if you will ask, if I have used three-phase system, power system, how to connect it? Okay, if you have connected three-phase, you can see this have 3 channel voltage input. You can let your L1 connect to your phase 1, L2 connect to phase 2, and L3 connect to phase 3. So this will monitor different 3-phase voltage, phase A, phase B, and phase C. But for this one, the CT sensor, the first 10 channel will work with this phase 1. So the phase 1, just phase A, the load, you should connect with this CT sensor parts. And the phase B, just phase 2, the load CT sensor connect with this CT sensor port. And the phase 3, just phase C, your load, you should connect with this CT sensor port. So this used for 3-phase, and also you can use N60 with a 3-phase, because N30 and N6 have 3 channel voltage at least. But N10 and N20 that only have 1 channel and 2 channel voltage detect. So that can't use for 3-phase. 3-phase only used for N30 and N60. Okay, this is how to connect with this power voltage line and the CT sensor, because every 10 channel CT sensor and the voltage managed by different energy meter chip. Just this one energy meter chip at here. Okay, this is the hardware about the sensor input circuit. Okay, now let's look at this is ESP32. I have said this is the first CPU, and the second CPU at here. Just this one. This one is second CPU. This ARM CPU will read this all energy meter data to this ARM CPU that have firmware inside running to read every CT sensor and voltage. But it will give the data to ESP32 and give the date to this one S485 A and B. So that means you will see this A and B is S485. This I and B is connected to this ARM CPU directly. So you can use Modbus to read this ARM CPU. This have saved all energy meter chip BL0910 chip date at here. So the resistance of Modbus you can read by ESP32 or by S485. This CPU read this date and save in this FRAM. This have a memory chip we have added here. So that if you power off, the energy meter data will save at this chip, will not clear set to 0, such as your energy date and energy total sum all at here. So power off is okay, no problem, will will save at here. So the CPU have read the date from any chip and saved at here, and the ESP32 will connect with this ARM CPU and to read this date from this chip. This is raw RAW date, just read from this energy meter chip. Our ESP32 KCS firmware never calculate the date, just read from this energy meter date, because it's deal with this hardware, not software. The hardware will read this CT sensor date and voltage and save at here, just at here. So this CPU ESP32 and this CPU only have 2 pins, have communication with each other by serial port. So this one and this one just cost, this one and this one just use 2 ESP32 pins have connected with this ARM CPU. They are work with Modbus protocol and work with serial port, just IXD and TXD. Later I will show you the PCB design in our compute. Okay, so this is 2 CPU work together, and this is a LoRa chip. So if you want to read this energy meter date wireless, no Wi-Fi, no Ethernet, no network, you can use LoRa, because this is a LoRa antenna. So if you have some different energy meter board, you can read this date from your computer by LoRa. So this LoRa module and this ESP32 work with the SPI bus. So they are connected with SPI bus. Okay, and this is the antenna of this ESP32. If you're using Wi-Fi, you can install this Wi-Fi antenna for ESP32. If you use Ethernet, just connect with the Ethernet socket directly. Okay, so and at here you can see there are some free GPL. You can see that is 15 and 16. So you can define your such as temperature sensor, humidity sensor, or different sensor in KCS firmware, or you can configure by ESP home. And this you can see have I2C, SDA, and SCL extender. So you can connect and extend your I2C device. And this is A and B IS485, and this is power, just 12 volt to 24 volt DC at here. And this one, that's USB-C, is download the firmware from your computer. And this is ESP32 download button and reset button. And you can see this also have a reset, IST reset. This reset is reset this ARM CPU. If you have forget the band rate and forget some settings for this ARM CPU, you can hold down this button that will read the factory setting for this ARM CPU. Okay. So this is N30 and N10 and N20 and N60 just have different small module, just have different energy meter chip count. So this circuit, all you see, the structure, all you see. So this is the hardware design details in PCB. Okay, we will complete to install it, and later I will show you how it works with software such as Modbus. And you can read in your computer. You can read any date, any energy meter date by Modbus resistant. And you can see this is CT sensor, the red cable and the black cable. But this one you can see the black cable at here and the red cable at here. I just want to tell you our new firmware can have the directions such as the current and the power. I will show the positive and the negative on the software. So this you can see the different cable directions. And you can see I have used the single phase, just AC 220. So you can see I have connect L1, L2, and L3 together. You can see and N1, N2, N3 together by this blue cable and this by red cable. So that can use by 4 of this CT sensor channel. So that means every CT sensor channel will have the first energy meter chip channel 1, and the second energy meter channel 1, and the third energy meter chip channel 1. I will test it. And this is the power supply and IS485. this IS485 I have connected with my compute because I want to show you how to use the Modbus Pro to read this energy meter data just from this Modbus resistant. Okay, and here that we are testing this socket. We just testing this socket. You can see the CT sensor just have connected with this socket. And this is the energy meter. We will compare the data. And this is the power. This power line, just this one. Just this one. Because I want to monitor the AC voltage. Okay, just at here. Connect with this Ethernet cable. And you can see this have a switch button, just to power on. So we can power on. And you can see this LCD display that will be loading. Okay, you can see now have showed the Ethernet IP address we can log in. And you can see the current is 0 and the energy is 0. Let's look at my compute. And you can see this is KinCony N10 and N20 and N30 and also have N60. Okay, let's look at this our PCB design details. You can see this is N10 and N20 and N30 and N60. So you can see this different, just have different small CT sensor channel, just energy meter small module. You can see it here. This one have 2. This one have 1, 2, 3, and this one have 1, 2, 3, 4, 5, 6. So we can see 3D mode. You can see 1, 2, 3, 5, 6, 7, and this 30 and 30 that you can see this have 3, and this N20 have 2, and N10 that have only 1. So other circuit, all the thing. You can see the circuit, all the thing. And the PCB, we can see the N30. For example, this video I will take the N30 for example. You can see the 3D mode. This have a ARM CPU. This ARM CPU only have this. You can see the ESP32 IO10 and IO9 have connected with each other together. So the ESP32, you can see these pins. You can see that will be turn right. We can let small, and you can see that have connect with the ESP32 pin, and this one you can see also have connect with the ESP32 at here. You can see the top layer. This you can see IO9 and IO10 at here. So the two CPU have connect with each other. Communication with the 2 pins, just the IXD and the TXD. And also you can see the different, such as the N60, they also have these 2 CPU pins. And you can see, I work with IO9 and IO10. So these only 2 pins with the ARM CPU. Just ARM CPU at here, this ARM CPU. Okay, so this is the 2 different CPU how to work together. Now we can look at in our form. This you can see we have released this KCS firmware that will support an energy meter board with this 0.001 energy meter data value. Okay, and at here you can see, for example, N30. I will show you how to read all data. And the easiest way that you use KCS firmware, and you can see, let's test it firstly. At the first, let's look at the KCS monitor web page. This is N30. Use the default username and password. You can see the KCS version. And we can go here, monitor web page. And you will see the date should at here. You can see the date should at here. Because this I have used before, so this have some data here. Now I will power on my heat. we can look at here. You can see the current will become large. This is the current. This is the current. At here you can see about 9 ampere. This one you can see about 9 ampere. And we can see this current and the power and the voltage at here. You can see the date. Now I will show you how to use the PC software to read this date. You just use the USB to ESP32. Open this software. You can download it from our phone. And set this compound and bandwidth and click open. And you can see that will read different chip. This means energy meter chip BL0910 every chip. Because I'm using N30, so you can see this have 3 chips. If you have using N60, you will also see this 3 chips. Okay, I have changed to low level, just about 4 ampere. So this PC software used for monitor all data. You can see the current and the power and energy, and you can see also have some voltage and the frequency and the power factor all at here. This is energy meter chip BL0910, the raw date, RAW date. So this is read from its resistance. Okay, so we can close this software, and the date also at here. But if you want read by yourself by Modbus, so you can see we can use by Modbus protocol at here. This is Modbus. In our phone, you can see how to read the Modbus RAW date by ESP32 at here. Because we have uploaded the Modbus config file, MBP file, that will be easy. You just open this file and you will see the different energy meter chip date. So that have showed how to use Mark 6 chips. And you can see this have the data structure, That total will have 68 resistance. You can see because the different date have different resistance count, all listed here. So you can see this is Modbus pole. You can open this file. You can see just this config file that you just connect and the USB port and the bandwidth and click OK. So you can see that will show the date. This will show the date by Modbus pole. At here you can see all the first channel have showed at here. First chip showed at here the Modbus date. You can see the current, the power, and the energy at here, and the frequency and the power all at here. And you can see at here we can set up a read. This is the 100 means first chip, first energy chip. And if you want read the second, because N30 have 3 chips, we can begin 20 apply. So that will read the different date. And you can see we can read the third one, just input 300. Okay, so this time you can see the watt will be negative. So because we have 2 directions of the CT sensor. At here you can see. So if you want 6 energy meter chip, you just input at here just 600. Because I don't have this, N30 don't have this chip, so you can see this is 0, nothing. So we can read from 100, 200, and 300 for different address. Because you can see that have showed at here that have showed at here. You can see the different, just only different address, and the count all is 68. The fifth chip, and the fourth chip, and the third chip, and the second chip, and the first chip. So this is how to use Modbus Pro to read the RAW date from ESP32. Okay, so this is Modbus Pro at here. And also you can see in our form, if you want to understand the Modbus protocol, you can see we have updated the document at here. This is for new ARM CPU firmware that have showed the Modbus all resistant and the date at here. So you can also download from at here. This is Modbus protocol, and this one is ARM CPU. ARM CPU. You can download the ARM CPU by this tool and by ESP32 USB adapt. Okay, this is N30, and this one you can see data structure that have showed at here. This resistant, how to read it, data structure at here. So you can see N60 you can use this 6 address to read all chips. N30 that can read 3 address, just this one 3 address to read all data, and N20 that you can see read 2 address of date, N10 that only 1 address to read all date. Okay, so that is, and this one you can see also have ESP home YAML file at here that support the newest ARM CPU firmware at here. Okay, and the next you can see how to choose this CT sensor. This is our CT sensor input circuit, and just how to choose this CT sensor we can list it here. Not must use 2001 this CT sensor, just use by this formula. And not let your CT sensor input greater than 700 millivolts will be okay. So you can see how to choose CT sensor. This is example, and if you want, don't use this one. Okay, so you can change it, but you should suitable for this formula. Okay, so this is the principle of the energy meter board hardware and the software, and you can read the resistance by yourself in anywhere. But in our KCS firmware, it will be easy to monitor at this web page, and also integrate to Home Assistant very easily, because we can support MQTT auto discovery. So if you have used Home Assistant, you can see this have an option. You can see this Home Assistant for MQTT. So you just enable this one, and I can rename N30. We can integrate to Home Assistant with their code. So just import your Mosquito MQTT IP address and the port and the username and the password. So you can see I can click save and click save, and wait for a moment. This will be auto found in Home Assistant. You can see this is reboot, and we can go to Home Assistant settings, go to this device, and go to device, and you can see if I import N30, that will show N30 device. Click, and you can see this one is found by MQTT. You can see the energy, current, and the power at here, and the total energy all at here. So the voltage you can see all at here, and this one you can see the negative, because the CT sensor we can change the directions of the cable, so that will show the negative or show the positive. this is positive, and this is negative because the cable is different directions. So this you can see have integrated home assistant very easily, just used by the MQTT Auto Discovery. I can just only input this information with integrated home assistant. Okay, this is N60 and N30 and N20 and N10, the energy meet principle of the hardware and how to read it by Modbus. If you have any questions, you can leave a message to us. Thanks for watching.